Okay, hi guys, welcome back to Think Tank. So in this video, we're going to talk about complex analysis. Okay, so I'll be looking at complex variables. Okay, so what we're going to look at, we want to find the harmonic conjugate of a given complex variable. Okay, so what we're going to use, what we call Cauchy-Riemann equations. Okay, so what we know is that our complex is in form of, okay, so let me just say z is in form of u for the real part u, x, y. Okay, since the complex variable is no longer a complex number, plus I, v, okay, v, x, y. Okay, so this is our complex. Okay, so in order to find this harmonic conjugate, first of all, the complex should be analytic. Okay, so how do you know that the complex is analytic? Okay, so what we know, if the complex is analytic, it should satisfy these equations. Okay, so we say these are called the Cauchy-Riemann equations. Okay, so we're going to say uxx plus uyy should be equal to 0, or vxx plus vyy should give you 0. Okay, so if this gives you 0, that means the complex variable given is analytic. Okay, so how are we going to find the harmonic conjugate? Okay, we're going to use the first order Cauchy-Riemann equations. Okay, so we're going to say ux is equals to vy. Okay, then uy equals to negative vx. So this is what we're going to use in this video. So we're going to save a couple of complex variables. Okay, so starting with this one, we're going to the other and other. Okay, so now we don't know if this function is analytic. Okay, so maybe in an examination you'll be told if the function is analytic, there's no need to first prove it. Okay, so what we're going to say, we know this is u. Okay, because this is a real part. Okay, so let's use uxx plus uyy should give us 0. Okay, so I'd say if you want to find uxx, so let's first start by finding ux. So differentiating this with respect to x, so we're going to get 2x plus 4. Now for uxx, we're going to get 2. Okay, so now we're going to uy. So uy, differentiating this with respect to x, we're going to get negative 2y plus 2. So for uyy, second derivatives, remember these are second derivatives, we're going to get negative 2. Okay, so let's see if our questions are satisfied. Okay, so we have said uxx plus uyy is equal to 0. Okay, so here uxx plus uyy is equals to 2 plus negative 2, and we're going to get 0. Okay, so we know that this complex variable is analytic. Okay, so now what we're going to find is the conjugate. Okay, so what we're going to use these equations to find the conjugate. Okay, so I'm going to use this for finding the conjugate. Okay, so we've said ux is equal to vy. Okay, so from here we know that 2x plus 4 is equals to vy. Okay, so we want to find v as a function of x and y. So what we're going to do, we're going to integrate here. Okay, so if we integrate, we're going to get a complex. So we're going to get v of xy. Okay, and here we're going to get, for 4 we're going to get 4y. For 2x also we're going to get 2xy plus. Okay, but remember we're going to get a constant, but the constant is now different. Okay, so let's say a given function, so let's just say f of x y. Okay, and this is equal to 2x plus 3y. Okay, so if we define this with respect to y, let's say f of y, we're going to get 3. Okay, know that, just see that x has disappeared because x is a constant if we define this with respect to y. The same applies here. So if we have differentiated this with respect to y, that means x, all x components have disappeared. So we're going to get our constant as a f of x. Okay, so now want to find this f of x. Okay, so what we're going to use, the second equation, uy equals negative vx. So we have uy, so we're going to say uy equals negative vx. Okay, so that means vx, we're going to divide both sides by negative. Okay, so we're going to get negative 2y plus 2. Okay, and this is equal to, okay, so we have a negative here, 4, okay, just 2y, sorry, minus 2. Okay, so this is the first equation. Okay, but we can find vx using this equation. Okay, so we have an equation in terms of v and in terms of y and x. So if we differentiate this, we're going to get, okay, so let me just name it equation number 2. Okay, so for equation number 2, so if we say vx, what are we going to get? Okay, so if we say vx, we're going to get 2y plus, okay, just remember, we're going to get 2y, only 2y. Okay, so now let's compare these equations. Okay, you see, we have, on the first equation, we have 2y and we have 2y, but, okay, on the second equation, if we differentiate with respect to x, what about f of x? So f of x is going to become, will become f prime of x. Okay, so look, now it's time for us to compare this equation. We have 2y, we have 2y, and we have f of x, and we have negative 2. So that automatically means f of x is equal to 2. Okay, so we're going to say f of x is equal to 2, let's say negative 2. Okay, so what is going to be our complex? Okay, so now we can write v of xy is equal to, okay, so we have 2xy plus 4y, and for the constant, what is going to be the constant? Okay, so we're going to get negative 2x. Okay, since this is f prime of x, so if you just integrate, we're going to get negative 2x. Okay, so this is going to be our harmonic conjugate. Okay, so let's say in examination, okay, you can prove, okay, so you can just equate these equations. Okay, so this equation, so this is a v component, this is a u component. Okay, so if you equate this, you're going to get. So now we're moving to the next equation. Okay, so in this question, what we're given a complex number. Okay, so we're given, okay, let me just say example number 2. So we're given 3x squared plus 4y minus 3y squared. Okay, and so I want to find the harmonic conjugate. Okay, so for this, we know that this is analytic. Okay, so let me just say here it is analytic. Okay, so what I want to do, I just find the harmonic conjugate. Okay, so what I'm going to do, we said first we're going to find ux, differentiating with respect to x, we're going to get 6x. Okay, just 6x. Okay, so now I want to find uy. Okay, so what is going to be uy? We have 4 minus 6y. Okay, so we're going to use our cautch-reimann equations. So we say ux should be equal to vy, uy should be equal to negative vx. Okay, so now that means we're going to integrate this one. So we're going to say v x of y is going to be the integral of 6x. Okay, so if integrate, we're going to get 6xy plus the function f of x. Okay, and now we're going to use this equation. Okay, so we are going to say vx is equal to the negative of v minus 6y. Okay, so if it makes vx with the formula A, going to see this uy is going to be, the negative of uy is going to be negative vx, and this is equal to 6y minus 4. Okay, so now we said we're going to name this equation number 1. Okay, and this one is equation number 2. Okay, so from equation number 2, let me write from equation number 2 here, we know that Vx is equal to 6y plus f prime of x. Okay, so that means we can now see that f prime of x, okay, f prime of x, let's compare them, 6y, f prime of x and 4. Okay, so that means we're going to say fxy is equal to 6xy plus, okay, so it's plus negative 4x. Okay, so if we integrate f prime of x, you are going to just add the x. So if we have 0, it's going to be 0. Okay, so we have 6xy minus 4x. Okay, so now we're going to another question. Okay, so for this question, okay, so now I want to find the harmonic conjugate of this one. So we're still using our Cauchy Riemann equations, so I'm going to write them here. U xx plus uyy should give us 0, or vxx plus vyy, so we need 0. Then ux is equals to vy, and uy equals to negative vx. Okay, so now we don't know if this is harmonic or not. Okay, if this is analytical or not. Okay, so for analyticity, okay, so I'm going to say ux here. So I'm going to get, what are we going to get? We're going to get 4x to the power 3, okay, minus 12x y squared, okay, plus 1. And now we're going to uxx. So for uxx, we're going to get 12x squared minus 12y squared. Okay, so for 1 is going to be a constant, so I'm going to say plus 0. Okay, so now for uy, okay, in the differentiating respect to y, I'm going to get negative 12x squared y, okay, plus what we're going to get here, we're going to get 4y to the power 3, okay, and second derivative uyy. Okay, so I'm going to get negative 12x squared here plus 12y squared. Okay, so if we say uxx plus uyy, we're going to see that this is equal to 0, 12x and negative 12x 0, negative 12y and plus negative 12y squared is going to be 0. Okay, so now I'm going to use these equations. Okay, so first of all, I'm going to use ux. So we said ux is equals to vy. Okay, and I have ux here. Okay, so I'm going to say vy is equal to 4x to the power 3 minus 12xy squared plus 1. Okay, then what is going to happen, I'm going to integrate both respect to y, so I'm going to get vxy. Okay, so it's going to be 4x to the power 3 times y minus 12xy to the power 3 over 3 plus y, plus what we're going to get, the function of x. Okay, so as you can see, I think if we can cancel here, okay, and get 4. Okay, so we're going to have 4x to the power 3 y minus 4xy to the power 3. Okay, so this is what we're going to get. Okay, so okay, plus y plus f of x. Okay, so I think you can add this one and this one. No, you can't add them. So this is x to the power 3 and this is y to the power 3. Okay, so now it's time for us to find vx. So you said we have got u, we say uy equals negative vx. Okay, so that means vx is going to be the negative of uy of 12x squared plus 4y to the power 3. So I'm going to get 12x squared y minus 4y to the power 3. Okay, so this is going to be our first equation for vx. Okay, so let's go to the second equation. Okay, so I'm going to say this is the second equation. Okay, so here if we define this with respect to x, so equation number 2, I'm going to say vx is equals to, okay, so we have 12x squared y, okay, minus 12c. If we integrate respect to x, okay, so I'm going to just get negative 4y to the power 3, okay, and I'm going to get 0 here plus f prime of x. Okay, so look, in this case, let's compare. Okay, we have 12x, so 12x, negative 4y, negative 4y, and we just have f of x. So that means f of x is equal to 0. So what is going to be our harmonic conjugate for the complex variable? Vxy is equal to 4x to the power 3 y minus 4xy to the power 3 plus y. Okay, just like that. Okay,